option. Display setting. It changes.
I think we should give everyone one more minute, Mohammed, as a lot of people have just joined in the last 30 seconds.
Is it better now?
Yeah, it's way better.
Perfect. 77 people. Welcome, welcome.
Yeah.
How do I stop having the... 81.
Okay. Do you wanna bet with me, Eric? I bet you like $5 it would reach like 95 by 1204. You wanna bet?
By 1204. Okay, wait. That's 10 more people to go. I think we'll stop at 105. I'll say 105.
Okay, 105. Wow.
For the sharing of the recording, yes. So we are recording this and we will distribute it after the webinar is over.
Awesome.
Oh.
90, 88, 89.
Come on, I'm missing 7. 7 people. Let me call my friends. Guys,
Well, soon if you go over, you're gonna owe Eric $5.
Ooh,
So.
oh! 9394. I like it. Yes, I won $5.
No, wait, it's still 12.
Yeah, but if it goes over
It's still
105, then you got to forward your $5.
Easy money, man. I knew it. Easy money.
Okay, so it's close to you.
Yeah.
Now Eric's bringing him all his duplicate accounts so he can get to 105 as well.
You owe me $5, Eric.
Yeah, let me activate my my bot accounts.
Wow, 100. That's good.
All right, I think 100 is a good place to start, as we've had a couple of people in here waiting for about 5-ish minutes now. We do want to stick to the 1-hour timeline. So just to introduce myself, hi guys, my name is Steven. I'm head of marketing and partnerships at Rocket Science, who is organizing this webinar. I'm just going to be doing the brief intro, explaining what we're doing today, introducing the hosts, and then after that, we'll get started. So let's get right into it. Eric, slide, please. Thank you. So on the agenda for today, the introduction, Mohammed is then going to do a brief piece on ML pipelines, and then we'll be demoing Airflow, Kubeflow, and Metaflow as promised, as well as doing a pros and cons of each one, and then doing a comparison. And we'll have time at the end to do a bit of a Q&A. So if you guys have questions, do stick around for that at the end. So yeah, well, I'll let you guys introduce yourselves, starting with Mohammed.
Yeah. So hello everyone. My name is Mohammed Sabri. I am the CEO of Rocket Science, and as well I'm an MLOps consultant. I have been working in consulting for the last 8 years in AI, data analytics, and MLOps. I teach as well part-time at the MIT through Great Learning, as well as at the University of Texas at Austin. Working as a consultant, what does it do? Basically, I help customers solve problems in the field of ML ops, design architecture, and implement efficient systems, production systems for machine learning. So I'll let you, Eric, introduce yourself if you want to, please.
So hello, everybody. I'm Eric. So I'm a machine learning engineer. I'm currently a freelance, and I have around 4 years of experience as an MLOps engineer, and also I got the opportunity to apply machine learning at massive scale using cloud and HPC. So I mostly focus on productizing machine learning projects in order to enable the clients and the companies to get value out of it. I'll give the floor to Yanzo.
Okay. Hi everyone. So I'm Zo. I'm Jans. I'm a machine learning engineer at Rocket Science, and I'm mainly focused on machine learning systems design. So my day-to-day looks like I'm building machine learning from scratch, like building all the software design behind it. Also, I'm about building algorithm there, put it in production, and monitor that. Yeah, thank you.
Awesome. So that's the team. Let's move on, Eric. I'll just introduce the org and then we'll just get right into our first pipeline. So we're Rocket Science. We're an MLOps managed service startup. We're founded in March of this year by Mohammed. And we've grown pretty fast since then. MLOps is a very hot field right now, as I'm sure a lot of you know. So we currently have 4 offices worldwide: Montreal, Los Angeles, Dubai, and Doha in Qatar. We're currently working on a first product as well. We can't tell you guys too much about it, but we're looking to create a tool that will really help machine learning engineers really like help optimize their pipeline, which is really exciting. So we're very excited for that. And we're very happy that everyone joined us today. So without further ado, Mohammed, if you would like to take over, and let's start with pipelines.
Good. What is an ML pipeline? I think that's a good question. Machine learning pipeline usually don't represent tools. It's basically representing workflow. All of you, if you're in the machine learning sphere, you're already doing ML pipelines. Your workflow, when you take the data, prepare them either by yourself or with the data engineer, then basically be able to pre-process that data, train your model, package your model, and then deploy it and potentially monitor your model. All that represent like the workflow, which is like your ML pipeline. Now, the question is not about if you do an ML pipeline or not. Is the most important question is how efficient is your ML pipeline? Because an ML pipeline that is not efficient is basically an ML pipeline that cannot scale. And one of the biggest challenges that companies, data scientists, machine learning engineers face is their ability to scale their pipeline. Because ML pipeline, whatever the way you're doing it, if it's one use case, one model that you have, it's very fine, you know. But when you try to scale to more use cases, more machine learning models, basically, if your pipeline, your workflow is not efficient, you end up basically not being able to scale. You need way more people to basically maintain your pipeline and be able to run it. If you go to next slide, Eric. So the most important question, after you understand what's the relationship between this Kubeflow and Airflow and Metaflow, one of the key questions that we try to answer with our customers is usually how to create an efficient ML pipeline. The first thing, most important thing, is in your ML process, you have to identify bottlenecks. A bottleneck can be potentially your CI/CD, can be your retraining process, can be your deployment process. That's really depend on how your pipeline and your workflow is designed. As well, always look for automation where it can apply. This is super important because an opportunity for automation is an opportunity to reduce man hour. Okay, you don't have to automate all your pipeline or your ML pipeline doesn't have to be fully 100% automated. Even large company like Google, like large tech companies, they don't necessarily have their ML pipeline 100% automated. It's suitable in some cases, in others it's not. Very important is always to keep in mind the scalability of your pipeline. What do we have in terms of workflow? Is it sustainable, and can it scale to more use cases, more machine learning, and more complex machine learning models? And always, this is super important. Always monitor your ML pipeline health, because your ML pipeline health is your ability to track metadata from your pipeline, to track your instances, to have visibility on assets created. All this is very important, because if you don't know what is happening in your workflow, ML workflow, you're probably not even capable of maintaining it and managing it and keeping it healthy. Next slide. So why do we look to automate an ML pipeline? The first main reason is to reduce man hours spent on maintaining existing assets. whatever type of machine learning model you do, if you end up in a situation where your workflow doesn't scale and moreover require you to have someone dedicated to that machine learning model and potentially to a part or a piece of your pipeline, and you see that if you wanted to scale, it requires more man hour, then this might become a problem. So reduction of man hour spent is the first most important aspect. Then of course the ability to reduce bottleneck, because if you reduce bottleneck, you reduce potentially the runtime of your workflow, you reduce as well the man hour, and you're capable of delivering efficient outcome out of your pipeline in a better like timeline. Then of course the ability to scale all the ML pipeline workflow. So that's the automation. And as I said, automating doesn't mean automate the full pipeline. You can automate a fraction of it, a part of it, or a bigger part of it. It's really depending on how basically the component or the aspect that you're trying to automate will bring value at the end if you do so. Next slide. One use case where it becomes very interesting to automate like an ML pipeline. This is a use case I presented in previous conferences as a workshop. So this is basically related to Reddit. So Reddit, for example, wanna have the ability to take some of specific like subreddit they have and be able to detect inappropriate content in them, because usually moderator will take the time to be able to identify if specific content in some subreddit are inappropriate content. And as I said, moderator are responsible for that. Now they've created a machine learning model that can detect out of comments if that specific comment is appropriate or not appropriate. Okay. The idea is, yes, they deploy the model and so, but now they realize that they want to be able to automate a portion of this pipeline and the workflow. And the portion they want to automate is basically the retraining aspect of the model. So anytime we collect enough information, and if you go to the next slide, Eric, I'll show the architecture. Each time they collect a certain amount of live feed from Reddit, they want to be able to retrain the machine learning model. So what have been done here is rebuilding a retraining pipeline based out of 4 components: and data extraction, data preprocessing, building classifier, and then trigger deployment. This is an automated training pipeline at the end that outcome a new machine learning model. And if after model validation and evaluation of the performance, the last component of the automated pipeline will trigger the redeployment, meaning that we have an ML engine that is live in production. And here we're capable of pushing another new model that will replace the existing model without necessarily changing the endpoint. So if it's an API, here it's the case, you don't need to change the endpoint of the integration. It will basically, your new model will replace the existing and you'll keep the same ML engine. So that's just an example of type of automation that can be done. It can be very sophisticated sometimes it can be basic and simple automation into your pipelines. So I'll let Eric take the lead for the next slide, and he will talk to you about Apache Airflow, because that's why you're here, guys, to see the comparison and the fight between the three amazing tools like Airflow, Kubeflow, and Metaflow. 3 ML pipeline or pipelines for automation. And I'll let you, Eric, start talking about Airflow. Thank you.
So hello, everyone. So I'll start presenting Apache Airflow, and then I'll also present Metaflow. So let's start a bit about Airflow itself. So it was created in 2014 at Airbnb, and it's now part of the Apache Foundation. And the version 2 was released was released around end of 2020. So currently the most up-to-date version is the version 2+, which solved a lot of issues compared to version 1, and it's kind of the one that comes back the most when it comes to the different tutorials and use cases. So originally, Airflow answers the need to orchestrate increasingly complex data engineering workflows, because you have different types of sources with different with a really different and a huge variety of data types. So it helps solving this complexity by orchestrating workflows. So instead of having pipelines, which is a sequential suite of steps, it leverages DAGs, which are directed acyclic graphs, and this allows to have some of these steps run concurrently, and this opens the perspective to be able to handle more complex workflows. The workflows are implemented through a Python library called Apache Airflow, which you can install with pip, and it's easy to get onboarded. However, once you begin, it has a pretty steep learning curve once you get into more complex things. Luckily, external resources can be relied on to hand on different tasks, and Apache Airflow uses integrations and operators. Let's say you can have a Spark operator do some Spark jobs that are outside of the Apache Airflow instance, so you can hand that to the cluster that is existing outside of it. And finally, you have two options when it comes to operating Airflow. You have managed service that are available through AWS and GCP. These are the ones that come back the most and that are the most known by the community, or you can operate it yourself on your own infra. The most common operation use case is on Kubernetes, and it comes with its own overhead. So let's jump into the demo. So let me share my entire screen, because I'll show you several things. So let's start by one of the most useful and nice things about Airflow. It's the fact that you have access to an interface which allows you to visualize your DAG. Right now we only have the hello world. However, I tried to do some tests by importing another DAG that has sklearn inside of it. So I'll be showing the DAG's documents, we'll be able to better understand why we get the type of error. So as you can see, by default, the jobs are more batch type jobs. However, there is the possibility to have more streaming type of workflows. I advise you to check the Apache Airflow community, which is really active and shares a lot of interesting resources. So yes, so you can have informations about DAGs. You also have more advanced security options, as well as audit logs, which is also really useful to see if a job failed, how it failed, what are the different events, etc., etc. So in order to have that DAG showing up on our Airflow instance, we needed to do some configuration, because natively Airflow itself doesn't have a versioning, native versioning option in order to import DAGs. So what I had to do with operating that Airflow locally, was to install a sidecar called git sync, which allows you to sync a git repo containing your DAGs with the Airflow instance. So in my case, I'm running Airflow locally using Rancher desktop. So as you can see, I have my instance running locally. If I do get pods, you can see it's running locally here and everything. And let me show you the DAGs themselves. So as you can see here, I use the Helm charts, which is a way that helps you dynamically change Kubernetes manifest to adapt an installation to your own use. So yeah, for those who are interested, I
have a question.
I can share that with you. Yes.
For you, probably the audience have the same question. How complex it is to install Airflow? I know the answer, but I still want to ask it, so you can share it maybe with the people. I know we're not covering the installation here, but maybe you want to give a hint to people.
So it took me so to do a simple installation and everything. It can take you half a day, up to half a day with really a simple installation like this one. You just spin up local Kubernetes cluster, but still you need to have a pretty powerful machine. And once you get that, you can rely on the Helm charts to install it. So it takes between half a day to an entire day if you want to make sure that you are configuring the tool like you want with all the tweaking and tuning. So as you can see here, we're using git sync, which references its own Git repository, and the folders here are inside the DAGs are inside this subfolder here called DAGs. So as you can see here, we import the Airflow library, which allows us to have access to a DAG object. So the DAG object helps us reference and describe, as well as give more parameters when it comes to scheduling and things like that. And also on the lines before, you can see that our different steps have been described as functions, but there is always the possibility to also have sub packages within the DAGs subfolder in order to have more specialized steps that are described, and then all can be imported into a file like this one. And then you associate each step to an operator, and then you call the object, which is the function that we described here.
Yeah.
In order to describe steps.
Could you maybe explain what DAG is actually? What the concept of DAG, high level?
Oh yeah, as I said earlier, it's directed as cyclic graph. So you have steps running one after the other. However, unlike a pipeline, you can have several steps that can run concurrently, and the following step can depend on these several steps that will run concurrently. So what it allows us is to shorten the number of sequential steps, and allows the workflow to handle some data fetching and some processing at the same time. So that's how I would sum it up.
Thanks.
We can extend over it, but I think we don't have much time today. But I'd be glad to do that later. So that's the first tool. That's about Airflow. So let's move back to the presentation and introduce our second tool, which is.
Sorry to interrupt. Could you please share with us your code after the meeting?
Yeah, sure. I just need to brush up some things, and
Stephen will share the video record, the link, the code as well, and everything link on GitHub. And we have a Slack channel as well for any further question about those tools and ML ops in general. But Stephen will promote that at the end.
Thanks. Please share us the link of the channel Slack.
For sure. Thank you.
For sure. Thank you. So before moving to Metaflow, let's talk a bit about the pros and cons. So as I said, Airflow helps us abstract complex workflow using DAGs. It also helps us automate queries and code execution. It has a pretty neat interface and helps to visualize workflow statuses. And there are many integrations with the outside tool through operators. However, as we mentioned earlier, there is no native pipeline versioning. You need to do a bit more tweaking before that. And there is no quote unquote easy way to do local tests. So in order for me to test my DAGs on my machine, I had to spin up a local Kubernetes cluster, and it's not everyone that has a laptop powerful enough to run the whole stack. And as we said, you can have a pretty easily, quote unquote, pretty easy install locally. However, operations on Kubernetes are complex. That's why many teams prefer going for the managed service ways. And finally, Airflow wasn't designed first and foremost for ML pipelines. It was first an ETL and data engineering job. However, if you need to extend the images of the different components of Airflow in order to have machine learning libraries like sklearn, as we saw earlier, you need to take the base image and build upon it by adding your required packages. So now let's move to Metaflow, which also helps data science teams first and foremost to put models in production and help their company solve their business problems. So let's talk a bit about Metaflow. So it was developed by Netflix originally, and it was open sourced in 2019. It was really designed as a human-centric framework for data science. So Metaflow is actually two things that are part of the Metaflow framework. The first one is a Python library that allows running pipelines locally and on the cloud. And then talking about this cloud stack, actually Metaflow is providing CloudFormation templates as well as the Terraform templates to supply infrastructure on AWS in order to help scale out these pipelines that were developed locally. So for the demo today, I will show you things that are run locally. However, I will mention what things can be extrapolated to the cloud. So let me move back to my screen. So as you can see here on my terminal, I have already shown Metaflow help here, and you get several options. So so the Python library can be installed with pip, and what it provides also is a CLI tool that helps you inspect and look at the different pipelines. So if I go into the Metaflow tutorials that were pulled from Metaflow tutorials pool, as you can see here, if I do a Python command and I call the first script here py and I do run, it will run it locally, and also it will provide many useful informations. So as you can see, you have a unique identifier to the run, as well as the different steps that are associated with it. And also Metaflow spins up Python processes with it. Locally, this will be stored inside the Metaflow folder, as you can see here. And this one will contain all the metadata information about it. So what we can extrapolate to the cloud is that this metadata information is stored in one unique S3 bucket that can be accessed through the use of the Metaflow library, as well as specific methods and objects that are provided by this library in order to access these metadata according to the run ID that is associated to a project. So let's do one more command, which is here, which is Metaflow inspect. Oh my bad, it's not that one. Oh, it's Metaflow status. My bad. So Metaflow status helps you have a look at the different available flows that were run that have information available inside the .metaflow folder. So now let's have a look at the code that runs these pipelines themselves. So as you can see here, it's a different approach where the pipeline itself is contained inside the class, and the name of that class will be actually the name of the pipeline itself. And the way you specify the steps of your pipeline, and also DAG, because in their documentation they specify ways to set up steps that run concurrently, is through the use of decorators. The same decorator approach is used to set up retry policies. So that's the first aspect of it. The second aspect of it is, as you can see, the pipeline is run through a main block here, and that opens the possibility to develop your pipelines through the use of an oriented object programming approach, which is also has its good aspects and its bad aspects as well. So yeah, so let me share this pipeline. Let's talk a bit about this pipeline. As you can see, it's a pipeline that helps to get statistics and statistics about some movie information from a CSV, but that can be extrapolated to data from a database, let's say. So once you run this pipeline, you'll have the metadata available somewhere, and the approach and the mindset towards that from the Metaflow side is the metadata is available. However, if you want to get information about a run or a metadata, you just need to access this metadata, and the Jupyter notebooks are actually the dashboards that help you do all that checking and monitoring when it comes to the status of these pipelines. I strongly advise to check up some videos done by the creator of Metaflow itself, where he explains that into more depth. So now let's recapitulate a bit about Metaflow itself. So first thing, it's the decorator approach to DAGs, which make things more lighter to read. It's easier on the eyes, and also it simplifies the way you write the code. There is also built-in support for parallelism. Locally, it will spin up new processes when you run it on the cloud, you can set it up in a way that run things parallelly on bigger instances or in a slightly more distributed way. The approach of having your pipeline inside the class opens the door for oriented object programming related designs when it comes to your pipelines. There is a huge emphasis on logging and versioning, so you can always check the metadata of your own run, and also this way of doing integrates really well with version control tools such as Git. Then the CLI tool helps you inspect the pipelines in a visual way on the terminal, and also since you have the metadata available in a folder or a bucket, it focuses on collaboration and managing complexity as a team through the sharing of the display of the information visually through Jupyter notebooks. And then for the cons, it's tightly coupled to AWS, and that comes with its own advantages and disadvantages. So you need to be aware of that. And also the Python library and the CLI tool doesn't run on Windows itself. Like as you might have noticed, my demo is run on WSL, so that helps with that aspect. So now let's move to the third tool that will be presented by my colleague Janzo. I give you the hand.
Yeah.
So.
Yeah, we'll take, guys, I see that there are a lot of questions in the chat, a couple of questions. We'll take the questions at the end when we wrap up the tools and we do the comparison. Yeah, Jens need me to enable, let me a second. Good.
Yeah, so thank you all, and thank you again. So now let me share my screen, and let's see Kubeflow. So first of all, let's see what is Kubeflow. So Kubeflow is an open source project, kind of toolkit built on top of Kubernetes for doing machine learning on top of Kubernetes, started by Google. And Kubeflow pipeline is one tool among that bunch of tools inside Kubeflow. So Kubeflow pipelines purpose is to help you to build and deploy portable, scalable machine learning workflows based on Docker containers. Yeah. So on very generally, Kubeflow pipelines help us to achieve reproducibility first. Why reproducibility? Because it's very important on a machine learning project. As a machine learning is an experiment, is a very experimental area. So you need to run again and again a pipeline. So you can experiment again and again as you want there. And after that, automation. Why automation? Because automation is very critical, since in machine learning, it can be, you can have a very difficult machine learning workflow since your team grows. Maybe some other team work on other specific tasks, and it can be very difficult when you try to manage that by hand. And last, reusability. Why reusable? Because maybe you need to share your work across other teams or other organization. So reusability is very critical on that point. Before jumping into our demo, I'd like to give you some insight about Kubeflow pipelines concept. So first of all, let's see what is a component. So component is kind of the most atomic part inside a pipeline. For instance, a component can be a features engineering or another part of your workflow. Component can be interlinked between them like a graph, and it's called an execution graph, as you can see here. Of course, the graph will be based on the logic of your machine learning workflow. When that graph takes some parameter, it's called a pipeline. So pipeline is nothing but a parameterized execution graph. So whenever you execute a pipeline, you call it a run. So a run is just an execution of the whole pipeline. So, and when you execute an individual component inside your pipeline, it's called the step. So basically a run is just the complete execution of all steps. Generally, people tend to group run together and call it experimentation. It can be the execution of one type of algorithm with a bunch of parameters, which takes a different value, and it's called an experimentation. So now let's jump into the demo and see you all of that concept from a more practical perspective. So first, let me show you the Kubeflow UI. You can see here the Kubeflow UI. You can see a pipeline rubric. We can upload pipeline from here. For instance, you can give some pipeline name here. Maybe I just upload a MNIST pipeline here through this interface, like giving a name here, checking upload file, and I've uploaded the MNIST.yaml file. So once you upload that, you have a pipeline like that, and you can see there your execution graph, and here you can see is YAML equivalent. Whenever you want to experiment or run, you can go to the experimentation and see here. You can see inside the experimentation that you have, for instance, a run, which is a different run. On a demo purpose, I can show you how to create a run. Let's choose this same pipeline and run name. Let's call it demo run, and choose an experimentation, for instance, this one. And you can see I've mentioned later that a run is just a pipeline which takes a parameter. We can change the parameter. Let's write 32. We can run our run can be visualized here like a graph. Just waiting for that. As you can see, the run here we have a step, and the pretty cool feature here is that for each step you can check the input as well as the output. You can check also the logs, like for instance, this one have this log since it are already loading, but we can see, for instance, for this one, you can see the logs here. You can see that we load a task, like we load data there. We do some training. You can see that we have an epoch, and so we train and we have loss and accuracy metrics, for instance. And then we have a task with the log. Like with the log, you are able to see that we have all of that task with that kind of accuracy. So what I really love with that Kubeflow UI, that it's really intuitive. So all of our pipeline are done, so we can see the logs. We have the same same accuracy that we have before, since we have the same input. That's why it's reproducible. So now let me explain you all of that, the code behind and so. So we can jump into the Python file. You can see here DSR pipeline. DSR is the decorator that helps Kubeflow to know which are our pipeline. You can see that function here. So that function is our execution graph. So here you can see train images, train labels, train test images, test label, train epoch, and train batch size. You can see that we have feed train epochs and batch size through our UI. So these are our parameter. And here, all of these, all of the instruction inside our code is our component. So load task is our component, as you can see here. And train task is another component that you can see here. Test task is another component that you can see here. So once you build that Python code, you can compile it and then have MNIST YAML equivalent. So that's the YAML file, which we upload through our interface inside through here. And yeah, that's all for my demo. So let's go to see what is the pros and cons for Kubeflow. So first, since Kubeflow is built on top of Kubernetes, it can be a double-edged sword. So it can be a good fit if your team have an expertise with Kubernetes, but it can be a bad fit if your team doesn't have that, since learning Kubernetes takes a very great time and have a very great learning curve. Another big pros concerning Kubeflow is that its ability to separate inside containers and communicate via files. So it's easy to transfer files through through containers, and it's more versatile. And some cons about Kubernetes concerning is that you are supposed to write all of that code inside here with that decorator, and then after that you need to generate your YAML file before uploading it through the pipeline. It's not a big deal, but compared to other framework, it's less manageable. So that's all from my end. I will give the floor to Mohamed, so he can wrap up all of that, all of the free tools, and give his insight.
Thank you, Yanzo. Thank you, much appreciated. All these are great insights, guys, that are being shared. So we have seen like some live interaction now about, oh, there you go, about the different 3 types of pipeline potentially that are actually quite popular. Airflow have been in the market for a long time, Kubeflow as well, and Metaflow is the new challenger here. The 3 of them work in a very different way, but they still serve the same purpose. The idea is to automate an aspect of your workflow, ML workflow. It can be the machine learning training model, retraining model, hyperparameter tuning. Can be your data engineering. You could potentially do ETL on Airflow or Kubeflow or even with Metaflow. In terms of comparison, this is a table where we compiled the different characteristics. You know, we're like, you know, the Sunday TV show where they compare cars, where we are the Wednesday TV show that compare between ML pipeline tools. The 3 of them runs on Python. Kubeflow supports only Python, Metaflow as well, which can be a problem in case you want to do pipeline on another language than Python. They all have like complex workflows using DAGs, which is good news, meaning because that's what you want. You want the ability to create potentially complex workflows on automated on every one of these tools. Kubeflow is a good fit for Kubernetes because it has been built for Kubernetes. The only disadvantage with Kubeflow is that it comes within a toolbox. Kubeflow pipeline comes within a toolbox called Kubeflow. And the problem is, if you want just the pipeline, you need to modify the manifest of Kubeflow to make sure to keep only the components that you need. Because if you take as is, it's basically a beast installation, and sometimes can be messy to install, especially if you do modification on the manifest to basically install the component desired. Decorator approach to DAG. Airflow has that approach, which make the code easier and simpler and more easy to read. Built in for support for parallelism. Metaflow does that, and I've seen a question around it, which is cool because with that you're capable of going faster while you run your pipeline, so your runtime will potentially be reduced. Kubeflow is separated into containers, which I like because the thing with Kubeflow, every component that you see inside inside the pipeline that Yanzo was showing is basically running as a pod. It runs temporarily and then it has a status as completed or terminated, which is cool. So it starts your component has to run. It starts a pod to run your specific component, then it's being shut down. It's object-oriented programming. That's definitely Metaflow. We've seen the demo of Metaflow and it runs OOP. So this makes it good for integration of your pipeline as a potential module. Interface help to visualize the workflow. Metaflow doesn't have an interface, so it doesn't have a UI, but Kubeflow and Airflow, both of them rely on good UI. Airflow have been created not for machine learning purposes at the beginning, but it can still be used very well for machine learning. But Kubeflow, when it was created by Google, it was mainly for ML pipelines. But the three of them have like that good ability of building complex pipeline for your work. Automates queries and code execution. That's more an Airflow specificity. Emphasis on login and versioning. This is definitely a Metaflow aspect where Eric was showing the ability to look for logs. Even if Kubeflow and Airflow give you access to the log, Metaflow goes on another level for your ability to have like that emphasis on logging and versioning. Integrating with other tools. Airflow has great integration. Kubeflow pipeline comes in a toolbox, so it has integration technically in the toolbox of Kubeflow. So you could integrate it with Celdon, and so even if the integration work can be complex sometimes. Metaflow is more new in the community of ML and ML ops. So probably we'll see within the next year contributors adding up more integration to Metaflow. It's a CLI tool that helps inspect pipelines in a visual way. Yeah, that's definitely a Metaflow approach, even if Kubeflow have like a CLI, but the problem, it's not dedicated for Kubeflow pipeline, but you can still, based on my experience with Kubeflow, you can still send pipelines like YAML files of your pipelines programmatically to the server. So basically you don't need to use the UI, but it's still a complex approach, but it's technically doable. Metaflow is more focused on the collaboration and complexity management, yes, but the new version of Kubeflow allow user management and is more session based, so you'll be able to have more like people on your instances, creating pipelines and working with your team. Native pipeline versioning, of course, that's Metaflow. We're realistic, guys. This is open source solution. So any aspect from a security perspective, and so your ability to manage aspect have to be is your responsibility at the end. So it doesn't come natively secure. You have to make sure that your tools and pipelines are being secured to avoid any leak of information and loss of information as well. But it has, as well as it's open source, it has the flexibility for you to do interesting and amazing integration with your existing solution. So before we go to the question and answer Q&A section, we have 4 open positions. So if you want to be a part of our great team and potentially do some great work on Kubeflow, Airflow, or even more complex framework on crazy use cases that we have, we're very open to have more people on board. We have an MLOps engineer position open, the product owner MLOps ML position open, machine learning software engineer position open, and senior software engineer Python open as well. If you want to apply, go on rocketscience.one/careers, and basically we'll get in touch with you if we feel that there is a fit with your current expertise. So I'll let Stephen, I think, get the floor before we move to Q&A.
So that's, I'm not sure, Mohammed, why that did load, but this is what some people were asking in the chat. So if you want to continue with your Q&A after this webinar, obviously after the Zoom closes, after the Q&A, it'll be hard to ask Mohammed, Jan, and Eric some questions. So here is the link to our MLOps community. So feel free to join that. It is a place to discuss everything MLOps, and to also where we're going to put job postings for future roles. If you as a company want to hire anyone, you can reach out to me on the Slack channel and I could have that posted for you. If you want to introduce yourself as a machine learning engineer or as a data scientist, you can also put yourself there as well. So we're trying to build an MLOps community where we'll help each other discuss and innovate the space. So the link is in the chat. Now we can move on to the Q&A, Mohammed.
Yeah, great. Thank you, Stephen. So yeah, Q&A section. I see that there have been some questions. You can still keep up, keep asking questions on the chat. I'll answer some of the existing ones. Someone was asking how MLflow compares to these 3 tools. Well, MLflow, even if it contains the word flow in it, which is cool as a tool, it has been created as an experimentation tracking and a surveying solution. It does many things. The first thing that MLflow will do is track your experimentation. So it's not necessarily like an automated pipeline, but it will be an experimentation tracking. So you run your experiment, for example, either locally on a notebook or even from Kubeflow, you run a pipeline. It's integrated with your MLflow server. It collects the metadata, the data, and the model. And you will be able to see your experimentation, the result, the model, the pickle file of your model, and so it tracks experimentation at the end, and you can use it as a model registry. So basically register your model and be able to flag it as a production ready model that will be sent to production. So yes, I've done integration between Kubeflow and MLflow, but as well between Airflow and MLflow. They integrate well with each other. MLflow has as well an option for ML serving. So basically, if you want to deploy your model, you can use MLflow serving. As well, a very cool tool initiative, MLflow, that has been created by Databricks. So yeah, that's it for MLflow. Do you have some tutorial to install Kubeflow on AWS? The version that was showing Zoho, Esteban, the version that was showing Zoho has been installed on AWS. If you go on Kubeflow AWS, I think, yeah, that's the documentation. And technically, if you follow this documentation, Kubeflow is very well documented. If you follow this, you should create an EKS cluster. And technically, it should be working. I've done it using exactly this documentation for this demo session. But yeah, if you have any specific problems, you can ask the question on the Slack community, and someone would probably take the time to answer your question. Another question is, yes, we have a question from Verenda around. Thanks for sharing. I could see in your last slide that Airflow is not given tick for parallelization. Could you elaborate on this? That's a good point. We didn't give a tick for collaboration, for parallelization for Airflow. Eric, as you covered the tool. Yes, I just. Yeah, go ahead.
So the thing with Airflow, it's not a tool that runs the computation per se by itself. It is just delegating the computation to different parts of an architecture. So with Airflow, you don't particularly parallelize. You're more saying, okay, run this task on this machine and run this task on that machine, and these tasks or steps themselves can be run concurrently at the same time on different machines. Okay. So that's why I didn't touch on Airflow and parallelization, because Airflow itself doesn't parallelize. It's more about orchestrating and distributing tasks across different machines. Then once it is distributed, then inside each step, nothing forbids you of having some parallel logic, but this parallelization logic is proper to the tool that you give the operator to.
Yeah, thank you, Eric. Akmel is asking, how have you find MLOps to be of value for companies that aren't serving up real-time value ML products? Well, I mean, that depends on what you mean by real-time high-value ML products. We deployed like ML models for example, basic forecasting models, and it's still doing very good and creating value to the company. And so ML ops is needed whenever you have ML at the end of the day. And without ML ops, like efficient ML ops, there is no high value ML product. There's only like notebooks and dreams. That's it. So definitely to create the last the value, you need that last mile, and that last mile is an efficient ML ops practice. The 3 tools support all Python, so why only Metaflow supports OOP? I think what we mean by Mamizoa, what we meant by supports OOP is basically the ability for Metaflow to be used as a module with classes in it, because that's what Eric was showing. It's as if it was a script that you will run. So it's built in its structure in a way that it can be potentially used as your script that you run. You could convert it to a module and call it from somewhere else, which become interesting. Where the purpose of if you see, for example, Kubeflow or Airflow, it's built in a way that you have to convert, for example, your Kubeflow Python file to a YAML file, then send it to send it to the Kubeflow server. Sergey is asking, for a career perspective, which of these 3 tools are the most widespread among the field? I would say Airflow have been there longer, so it's the most popular, and Kubeflow as well is very popular. So those tools are the most popular. Metaflow is gaining more and more traction, so it's some sort of challenger in the industry. Which tool is the most cloud agnostic? I would say Kubeflow is agnostic, except that it needs Kubernetes. Airflow can be installed on any cloud. Metaflow is more on AWS. There is a possibility to guarantee communicate to the downstream task termination state with batch operator on Airflow. Eric, for this question, what would you say for Airflow? Let me unmute you, Eric. There you go.
So I haven't looked into the details of that type of issue, but I'd be happy to answer it later, Jonathan.
Yeah.
Get in touch with me on Slack, and I'll see how I can help you with that specific issue.
Yeah, if you want, I think you can. Someone is asking about installing Kubeflow. You can install it locally as well. All the most efficient, the most detailed documentation is available on Kubeflow community website, and you can install it on different cloud provider, but as well locally. If you go, I think on minikf, and Kubeflow as well supports OpenShift for those that were asking. Yeah, Zoe just sent. Does your product support online machine learning? That's a good question. Online machine learning. When you mean online machine learning, do you mean like model that we learn potentially in production? That's what you mean by online machine learning. So model that you don't train offline, but that will be trained in production. Just trying to understand what you mean by online machine learning, to make sure that I'm answering it properly. So meanwhile, I'll take the other question. Isn't the boat online means streaming data, I guess? Okay, yes, streaming data. Yes, correct, using streaming data. Yes, you can use, but that's the thing. Your pipeline is not done for necessary like live stream. So it wouldn't take live stream because that's not a Kafka streaming tool, but it can be used like I did, like I was showing, and I did with here with this use case. Yes, here a part of the live feed is being stored a row and then being consumed by the pipeline. So technically we're not in a streaming approach for the pipeline, but we can consume streaming data coming from a live feed or IoT or any other. So, but if you want to do streaming, I would advise more tools like Kafka that are more served for doing streaming. Here we're really in an approach of automating pipeline, and more specifically training pipeline, retraining pipeline, data engineering, more than ingesting data in a streaming approach. Isn't the both way require learning? Well, I think for data science to learn how to use those decorator, understand about how the Turing case. In the other hand, you can have standard data science code by data scientists and ML with to create the YAML for Kubeflow that also kind of create agility in the data science team. I think that's an interesting like thought you had here, Safwan. So oh, which tool do we use at Rocket Science? I mean, we're very agnostic, so depending on the context, we might be using one another. Of course, because of the popularity of some tool over others, we work more with tools like Airflow, Kubeflow, but we hope that in the future, Metaflow will become more popular, but depends. I mean, So far, a lot of companies and so they work a lot with Airflow for data engineering. Kubeflow has its popularity and is an interesting tool as well, especially that it's machine learning focused. Great. I think we're good. Like Stephen will send back all the information with the presentation and we have our Slack community where you can basically ask more questions and have an open discussion with the community, but as well with us. I'll let you, Stephen, close this with the last word, and then we can free up people time so they can go back to work.
Yeah. Am I unmuted?
Yes, sir.
Awesome. So thanks everybody for joining. This was Rocket Science's first webinar. We're very happy with the turnout. Almost 30% of who signed up for the webinar turned up today. So we're really, really happy. I saw we already have about 40 people who signed up for the Slack community as well, which is fantastic. So we're really, really happy about that. We're really excited for the direction in which MLOps is heading. And we're happy to be at the forefront of the community, really helping you guys learn more and being kind of a knowledge center to share everything about MLOps. So expect more webinars in the future, probably about once a month or once every 6 weeks, but we'll be touching up on updates on LinkedIn and also on our Slack channel. So feel free to connect with us on LinkedIn as well. If you go into the MLOps community, you'll see that there's an introductions channel where you can introduce yourself, who you are, who you work for, what you do, and also drop your LinkedIn as well so that we can connect with you. So have a wonderful day, guys, and thanks for joining.
Thank you, everyone. Thank you. Very appreciated. Have a good rest of the day. Everything will be shared with the codes in the community, as well the presentation and the recording of the video. So don't worry about that. It will be shared with all of you. So thank you, and have a great day. Thank you.